Hi Shivam,
Hi sir.
how are you?
Sir, fine.
Okay, so introduce yourself first.
My name is Shivam Kumar. I am doing training from FutureWix and a student of Manavachana University. I am doing BTech in EC, specialization in VLSI from Manavachana University.
Okay, so what you have prepared for today's presentation?
Sir, I have prepared MUX.
Multiplexer.
Yes.
Okay, so can you explain what is MUX?
Sir, MUX is a combinational circuit and that has 2 raised to power n input and 1 as a output. And in where 2 raised to power n we give n as a selection line.
N as a selection line. Okay, okay. So why MUX is known as a universal circuit?
So because from MUX we can implement any logic gate and universal gate also.
Can you explain me with taking example?
Yes, sir.
Can you design a NOT gate using MUX?
Yes, sir.
Okay, please.
So basically I have taken A as a selection line
Okay.
and for input so the expression we will get so that it will be a NOT gate.
How I would know that this is connected to or this one is connected to I naught and this ground is connected to I1. You have to mention internally,
Yes,
na?
sir.
You have to mention internal connection that which one is I1 and which one is I0.
So I
Now
have
it is correct, right? Okay. So see, whenever you design anything, whenever you explain anything, it should be clearly mentioned. There should not be any ambiguity, right? Okay. Perfect. What are the applications of MUX other than this logic gate implementation?
Sir, we can use MUX in digital communication system like we use techniques like TDM and FDM, which is stand for TDM stands for time division multiplexing
Okay.
and frequency division multiplexing FDM. So basically what we do is that we give some inputs through MUX and this convert into DMUX and we get our output. So here we can use our multiplexer as an input.
Okay.
And in TDM we give n channels and through multiplexer we pass them and we get a single channel.
Maybe another application?
Sir, data selections line.
Data selections. Okay, okay. Suppose I want to design a MUX with 100,000 inputs.
Okay.
So how many selection lines I would need?
1000 line.
Yeah. 1000 inputs I have. Okay. Out of 1000 input, I have to select one. So how many selection lines I would need for that?
10, sir.
10 selection lines. What is the criteria basically?
So we take selection lines in 2 raised to power n. So here we will get 2 raised to power n, 10. So basically it is equals to 1024.
24.
So from here I get.
Or maybe log base 2n.
Yes, sir.
Right? Okay. So whatever the number of inputs are there, we will get the log base 2 of that number of inputs. This will be the selection lines.
Yes.
Okay. See, we have higher order MUXes.
Yes, sir.
Can we implement it with lower order MUXes as well?
Sir. I can implement.
Like suppose I want you to implement 4 cross 1 MUX using 2 cross 1 MUX.
Sir.
Can okay, please show me.
We will take 2 cross 1 MUX 2 times.
Okay.
And we will connect single selection line to both of them. And we will need one MUX also for their output. And 4 cross 1 we have to implement with 2 cross 1 we need 2 selection line because 4 is 2 raised to power 2. So and here we have to understand one thing that we have to take our selection line from LSB to MSB. Okay. So we will take like that we have S1 and S0. So we will take S0 here first, not S1 there. So from here we can get our
suppose I have a S1 S0 combination as a 0 1. 0 and 1. Okay. So what should I get as output?
So if S0 is 0, we will check first. So I0 will be selected from here. Okay. And from here I2 will be selected.
Correct. Okay.
And here S1 is 1. So we will get I2. So we will use I2 as our answer.
Okay. And what about the 4 cross 1 MUX? 4 cross 1 MUX also will get I2?
Yes.
So your circuit is correct, right?
Yes.
Okay. So you have to verify also your circuit, right? in this case, like suppose you have implemented 4 cross 1 mux using 2 cross 1 mux, how many muxes you needed? 3.
Three
Okay.
mux.
Suppose now I have 1024 cross 1 mux.
Okay, sir.
So how many such 2 cross 1 muxes will be needed?
1023.
1023. What is the simple concept?
Sir, this is very simple, that if we have to implement any mux using 2 cross 1, so we will take one less than that mux.
Whatever the number of inputs are there, minus 1 will be the
Answer.
number of mux requirements. Okay. Just make a circuit. I am giving you description about that, and what will be the output of that. Suppose I have two cross 1 muxes. Okay. Just draw 2 cross 1 muxes. 2. Okay. So I naught of first is grounded. Second, I1 is 1. Selection line is A. Then second mux.
So continues.
Yeah, just cascade it. Okay. So output is connected to the selection line, and I naught is again 1. I naught of second one is 1. Okay, and I1 is grounded. What is the output of this final mux?
Okay, sir.
Just tell me.
So from here we will get our expression as, if I take y as, so here we will get A from first mux. Then we are using it as a selection line. Then from here I will get, so I will get A bar as an output, sir.
Okay. Can we implement sequential circuits with mux as well?
Yes, sir.
Like I want to implement a latch.
Yes,
can
sir.
you explain me?
Yes, sir.
Yeah, please show me that how a D-latch can be implemented using mux.
That is Q only.
Enable.
Yes, sir.
Okay.
So if any output is 0, we will connect to. So that will be as a using 2 cross 1.
But what is that Y? That Y should not be there, na? This should be Q only, na?
Yes, sir.
Okay, this should be Q only. So in your table also that should be Q. So whenever enable is 0, it will be in no change condition, right?
Yes,
latch. And how a latch can be extended as a flip flop?
2 master slave will be used.
Master slave flip flop. Okay. So you're done. Good.
Thank you, sir.